So this is looking at Venn diagram and conditional probability, which we can see from the notation there straight away. So the first thing with a question like this, before you can go and answer the question, is to actually draw a Venn diagram to represent the information here. How do we know it's a Venn diagram? Well, we've got intersection of certain things with A, with B, certain things happening together. So let's try and represent it in a Venn diagram, which is a form of a sample space diagram. So a Venn diagram, remember, should have a rectangle to represent the total sample space, all the outcomes. We've got event A mentioned here, which is to do with someone playing snooker. And we've got event B, which is to do with someone playing pool. So I'll write those down first. There are a total of 120, so we're dealing with frequencies here rather than probabilities. So keep that in mind. Given that 65 play snooker, so that means that the circle A or the curve A should contain a total of 65. So given that 65 play snooker, so what I'll do here is I'll just go and indicate that everything from there to there, that whole thing is 65. And then it goes on to say 50 play pool. So that means all of this here, the whole circle B, should contain a total of 50. And 20 play both means the area inside here is 20. So if the area inside is 20 and we know the whole thing for B has to be 50, obviously 50 take away 20, that gives us this has to be 30. Likewise, if we know the whole thing for A has to be 65 and we know the middle section is 20, 65 take away 20, that gives us 45 here. So once we got the actual correct frequencies, I can then rub off the other bits that I used in terms of working things out. So now I've got my frequencies, correctly written for that part. Now I know that there are a total of 120 members of this youth club. So the total must add up to 120. So what we have outside here, those who don't play either snooker or pool, should be 25. Okay, just use the same color here, 25 here. So now my total adds up to 120. Now we're at a stage where we are ready to answer the question. So part A is asking us to find the probability of A intersect with not B. Now, first of all, let's take a look at where A is. Now, A is all of this, but we're looking at the intersection of A with not B. So I'm going to go and highlight not B now. Now, remember, not B is all the area that is outside of circle B. So if I shade everything outside of circle B, notice the part that gets shaded twice, i.e. the bit that is intersecting with A, is what we are interested in. So what I've done is I've shaded everything outside of circle B. And the part that's been shaded twice, as you can see here, has been highlighted automatically in green. So really what we're looking at here is A intersect not B is represented by this frequency here, 45. So the probability of A intersect not B is equal to 45 out of the total, which is 120. Since it's not conditional probability, it's out of the total. Okay, so that's the answer to part A. Okay, it's 45 out of 120. Let's go and take a look at the second part, then part B of the question. So part B is saying find the probability of A given that B's happened. So A given B, let's go and take a look at that. A given B means we are only looking at out of the restricted sample space of B because B's happened. B is everything inside circle B, so it's out of 50 now. And what's the probability of A happening? Well, the only part within B that we are interested in where A is happening, if you see, is just that 20 bit. Okay, so it's going to be 20 out of a total of 50. Part C says find the probability of B given not A. So again, I'm going to start by highlighting not A because we are restricting our sample space to not A. It's a conditional probability. So first of all, I'm going to go and highlight not A. Not A is everything outside of circle A. So I'm highlighting everything outside of circle A. this is the sample space that I'm going to be considering only. It's out of all of this, out of the not A. So not A, what is that total? Well, it's everything outside that, and we can see it's out of 55. And out of that space of not A, which part is B? And we can see that there's only 30, which is within the B there. So it's 30 out of 55. Okay. And lastly, part D is probability of A given A union B. So similarly, I can go and take a look at this. First of all, let's restrict our sample space to A union B. A union B means unite A and B together, and it's the whole of A and B shaded there. So it's out of this. This is my restricted sample space shaded there. So it's out of that total, and that total here we can see is 95. So it's out of 95. So out of this A union B, how much of it is A? So we can see in A, the circle A, there is 45 and 20. So it's a total of 65 there. So it's 65 out of 95. And so that's how we tackle conditional probability with Venn diagram. We restrict the sample space based on what has happened, what they say has happened, given that this has happened.